agree on or have decided on is a good template to follow on how to answer the question. And then obviously we're not right 100% of the time, but it's sort of like what's worked for us. And yeah, feel free to add on to it. So no one volunteered about this, and that's kind of scary. It can be like 2 or 3 sentences, just like a quick.
Woo! That wants to do it.
All right. Hey.
Yeah.
So yeah, you can stand up, you can sit, whatever you want.
I'll just say
Cool. Yeah. Tell me about yourself.
All right. So I'm a first-year computer science student, and I have a passion for doing machine learning. And so basically, I like working with algorithms, machine learning algorithms in general. And I also like exploring the field of cybersecurity, where you can apply machine learning. Aside from computer science related stuff, I also like playing sports, mainly basketball and soccer sometimes, but mostly basketball. And so those are like my interests in general.
Sure.
Yeah.
Cool. So hopefully you see it's not as scary as you might think. Go to the next slide. So this is sort of like a template about like what we've decided to like talk about. So one might be the current role, like what are you doing right now, whether that's a student, whether you have a current internship that you're a part of, whether you're working on a personal project that you're really passionate about. So you can talk about college, so that could be like your academics, like what courses are you taking that are interesting you right now, extracurriculars that you're doing, this could be like org involvement, it could be the fact that you're an ACM member, that you come to our meetings every 2 weeks. It could be internships that you had, personal projects you're working on, like I said, hobbies that you have. So these can be technical or non-technical hobbies. So Het talked about sports, which is sort of like an interesting in to talking to someone about, right? Like you don't always just want to talk about something technical and be like, oh, did you watch the game last week? And then your passion and your interest should show through. So like at the end of you telling them about yourself, they should have a pretty concrete idea of like what you're interested in and what you're passionate about. So for example, like from what Het told us, we know that he's interested in machine learning, and particularly machine learning's applications in cybersecurity. So he really left us off with that impression, which is good. Go ahead.
So I just wanted to add on real quick is that this is really important because most of the companies are in an agile kind of methodology, so you will be placed in either a small development team or a Scrum team, and the whole passion and the whole type of person that you are is really important for them to put you where you're most comfortable with.
Yeah. So it's like the first step of team matching. So when you do get the offer, they know sort of what team you're on.
So like how long would you be talking about?
I would say like 60 to 90 seconds. Like really nothing more. If it's shorter, it's fine. It just means you'll move on to the technical rounds faster. Yeah. Just be sure to kind of like touch on everything that you want to touch on. Okay. So this is a little harder question, I would say. So this is like, tell me about a difficult technical feature or bug that you've worked on. Anyone want to volunteer for this? Sure, James.
One of the typical technical feature I worked on was over the summer with my undergrad research. Like the problem was like we were trying to get some images printed out, but like the lines were like not looking right. So one of the things that we did was like looking to stream our entire package, like using like using package libraries to give me fix that issue, and now the actual way to fix that issue with just minor tweaks to your algorithm.
Nice. And so you don't rent that actually anymore works now?
No.
It doesn't work?
I mean, it works perfect.
Okay, cool. Okay. The reason I asked that, you'll see. So go ahead and go to the next slide. So when you're thinking of something that you've solved, you first want to think about a problem that you've encountered. So try to think about projects that you've worked on. Again, this could be stuff from internships, personal projects, even like classwork. So like for example, I'm in CS 100 and there are still parts of assignments that are difficult for me and that I don't know how to do yet. So it could even be stuff like that. Like I didn't know what a system call was, but I had to look it up and there was documentation, I read it, and I figured out how it works. So what was particularly difficult about it? Maybe the documentation was sparse and I didn't really know how to read it. So talk about what was difficult about it. How did you fix the issue? Talk about how you work collaboratively with other people. So that's huge. They want to make sure that you know how to work with people, right? Computer science really isn't a solitary career path. You always have to be working with other people. So obviously, if it was just a personal project and it was just you don't have to talk about how you were working collaboratively. And how did you prevent the issue from popping up again? So it's great if you fix the issue, but if another edge case just pops up like right after it, then you didn't really fix an issue. You kind of just introduced a new one. So try to make sure that the solution that you present actually fixes the fundamental issue, not necessarily just an edge case. So technical. So the purpose of a technical question isn't to see that you know how to code, right? They're going to assume that you know how to code because, one, you're at college and you're going through CS courses, and the fact that they even got back to you, right? And you assuming that you're at this round, it means you passed the behavioral round, which means you're like a living, breathing human. So the purpose of it is to show how you think through a problem, right? Like, what's your approach when you think about how to solve a problem? Like, where do you start tackling the problem from? What sort of questions do you ask? What do you care about when designing an algorithm to solve something? So go ahead, next slide. So this is a pretty easy question, I'd say. So given two strings, write a method to decide if one is a permutation of the other. So I am still taking volunteers. If anyone wants to, there's a whiteboard, we have markers. Anyone want to come up and solve this? You can take some time to think about it. Anyone?
Question.
Yeah.
What is a permutation? Just to
Oh, sure, yes. So this, do you want to come to the board?
Sure.
Yeah. So you're definitely off to a great start, right? The first thing you should do is ask a clarifying question. So in this case, I would say a permutation. Two strings are permutations. So I would say two strings are permutations of each other if they have the same amount of characters. But the strings can be rotated or just moved around in anywhere.
And like same amount of characters, or like
So
the exact same characters but rearranged?
The same amount of characters, but they're just rearranged. They could be rearranged. It could just be the same string. You never know.
Okay. And the question was
Decide whether or not it is. So a Boolean term would be fine.
do you want this to be part of a function, or like?
You can write a function that accepts two inputs and returns a Boolean.
Am I fine to use whatever language I'm?
Yeah, you're fine.
Cool.
What are you using?
C++.
Okay, that's fine.
So bool permutation.
Sure.
And like you said, I can take two string.
Yeah. And just as a side note, no, just keep doing what you're doing. As a side note, he used short variable names because he's gonna have to write these several times. So it's good to choose short variable names. Just mention that in real production code, you wouldn't have your variable names be that short. You would have them be a little more descriptive.
Well, if we're going by permutation,
Yeah.
I guess you would just check if, well, first things first, you need to check if this one is the same size.
Okay. What does that tell you if they're not the same size?
That it's not a permutation, right? Because if they're not the same number of characters in this string, then that goes against what you told me.
Sure.
So, s1.length. And I guess I could say return false, and depending on how I implement this, I could use it to determine whether these two are permutation.
Okay.
Would there be, can you give me an example of a case where this wouldn't work? Because
Sure.
from what I'm understanding, that they just have to be the same.
So I can give you bat and cat.
Oh, so you're saying? Oh,
Yeah.
okay.
So for example, this is
That
another sort of clarifying question you should ask. Is like, so for example, if I give you bat and
Yeah.
tab, this would return true,
Okay.
but this would return false. So you need to have the same amount of every character, but they could be mixed around.
Oh, that's.
Yeah.
I thought you just meant the length.
Sure.
Okay.
So can you? This is a good base to have your solution on. Can you
Yeah.
build it to include these sort of test cases?
Well, if I'm looking at this, the obvious answer to find this would just be to check for reversal. But if I had a super long string, and like reversal would need to be
Sure.
every single way. So
Yeah,
if I had a
and-
super long string, it'd be hard to notate every single character.
And reversal doesn't really work because I could give you BTA,
Yeah.
and it should still return true. Yeah.
Are we allowed to ask questions as well? Like,
Yeah, you can ask them in
Will
general
there be
questions.
duplicates of the same letter?
So give me an example.
Like if there is multiple A's in a word?
Yeah, there could be.
Yeah, okay.
If I give you the string batarang that has multiple A's.
Yeah, okay. I see.
I wouldn't be able to do something crazy like adding together the ASCII values and then like checking if they're the same.
No, because yeah, that wouldn't work. Because you could have like A plus
Yeah.
B is the same as like some of the two characters. that
Like
are-
maybe it would work for something simple like that,
Sure, but that wouldn't scale.
yeah.
So, how I would start approaching this is, can you keep a count of every character that you come across in one string,
It's like
and see if the second string also has those characters.
the problem with that though is like when you get bigger and bigger and bigger, it just gets harder, right? But would I still be able to?
Sure. So, what if I told you you're allowed to use like you don't need constant space. You can use some sort of other data structure to manage that for you.
So then, how about I just use
You can just
a?
write on that board if you want.
Okay. Right. Well, if I can use more than that, then the first thing that comes to mind when we're thinking about like storing the numbers for certain things is like vectors, right?
Sure. So, vector could work. I think there's a better data structure you could use instead.
Vectors, what's that now, man?
Okay, that's fine. Does anyone else know of one that you could use that might work better?
Like something that would let me
Yeah.
take this and give it
Can
another.
you just use the set?
A set would work if you only had one occurrence of every letter. We might have multiple. Yeah,
Can we use the map?
you can use a map. So,
Right. How would I use it?
sure, that's fine. So if you don't know how to use it, this would be a perfectly fine like way to ask how to use something. So okay, you can think of a map as an arrangement of key value pairs. So basically, you
Don't
could
know what
have
key value pairs.
that's fine. So you have like a letter A,
Uh-huh.
and you can say this has a count of 2.
Oh, this is similar to a JSON file.
Yeah, exactly. Have you worked with like JavaScript before? It's like a
very,
JavaScript
very,
object.
very little.
It's like a JavaScript object.
Okay.
Yeah. So you can say like, you can do stuff like map of A plus plus, and we add that count.
Okay.
Yeah.
How would I notate this in C++?
You can do it exactly like this. So like whatever, so the syntax is similar to a vector file. So it's like map, and then like your character, comma, int. Where the first one is your key, and the second one is your value.
Okay.
Yep.
But it wouldn't be visually represented in
No.
color like this. Okay.
If you want, because you're not really familiar with maps, which is fine, can you tell me the general sort of like, without code, can you tell me the sort of general approach you would take to this? And then we can base it off of that. And then if someone else wants, they can come up here and write the code.
Well then, I guess I would just loop through the first string. And
Hey guys, can we quiet down a bit just for the people who want to listen and are trying to listen?
So loop through the first string. I'll look at the first character and grab the first character, whatever that is. In that example is B.
Sure.
And keep going. So every time I encounter a new character, then I add that as a variable in like my
Okay.
proverbial JSON
What
file.
value should you have?
Definitely 1
Okay.
for the first occurrence.
And what if I gave you rabbit, and you run into a second B? What would you do here?
Then I would use a secondary loop. So during during the first loop of the first string, within that loop, I have a second loop going, checking the, I guess, the map that I just made
Okay.
to see if the letter that I'm looking at right now is within here. So it would look like 4, go through the string,
Yeah. Yeah, and that's fine. You can write like pseudocode kind of.
string, right?
Yeah.
Then and then another for loop within there to go through the map
Okay. To see if.
I've gotten one of
Okay,
these
sure. So
variables
you don't
in
need a second loop. What you can do instead is you can say map of A, and this either returns a value or it returns null.
Oh, so if map of whatever character I'm at right
Right.
now is not null,
Right.
then I would just, if it's not null, then I would add just 1 count to
Cool.
that part of the
Okay,
map.
that sounds good. So now you've gone through the first string and you have a map, right? So for example, say I gave you a string with 2 B's, all right? So your approach correctly does that. Now I give you tab with 2 B's, that's my second string. How do you correctly identify whether or not this was a permutation of that string?
Then I would have to run the exact same loop that I just did for that one,
Right.
and run it through this one, and then cross-check the values.
Okay, that sounds perfect. That works. That's a working solution. Yay!
know too much about the like higher complexities, like time and space
Sure,
complexities.
yeah.
Would this be like one of those
This-
lower ones?
This
or-
would be a good time and space complexity. Does anyone know what the time and space complexity of this code is? Anyone?
About like
Time space.
Got like
Yeah,
two
so it's O of n time. What about space?
Good question.
That's a good question.
Open space.
Yeah. So it's O of n time and O of n space, both ways. So the reason it's O of n time is because you're going to be iterating through the entire string, which is the length n, and it's O of n space because you're going to be storing a key value pair for each letter in the string, for each unique letter in the string, which at worst case scenario, all the letters are unique, and you have to store one for each character in the string. So O of n space, O of n time. Got it? Cool. Thanks for volunteering. So this is a general sort of approach to technical questions. So always ask for some example input outputs. You'll notice that I didn't actually provide it. So that would be a good first question is like, can you give me an example? And that usually gives you more of an idea of what the question actually is and what I'm asking for. So what else can we ask? Does anyone know some other questions? He did ask a couple. Can anyone think of some other questions they could have asked?
I had an interview actually, and he asked one question.
Sure.
He said, find how many. So assume you have a string. Find how many characters how many instances of a specific character there are.
Okay, sure. So that's like half of this problem, right?
Yeah.
Where it's like you don't check to see if they're identical. You just do the first part and you make the map and you can just return the map. Right?
I did it differently.
That's fine. But yeah, so like it's very similar to this question.
Yeah.
So yeah, it's a good question to ask. So I sort of mean like, what sort of clarifying questions can we ask when I give you a question? Like if I'm an interviewer and I give you a question, what's a good clarifying question?
Do you care about capitalization?
Yeah, so if I say I were to give you the strings God with a capital G and then dog all lowercase. So that would be a good edge case, right? Like do we care about capitalization? They are different ASCII values. Do we actually care about that? Yeah?
Space and time complexity, what do you prioritize?
On what, sorry?
Do you prioritize space complexity or time complexity?
Yeah, so that's a great question too, right? Do we want to optimize for space or do we want to optimize for time? In different scenarios, we want to optimize for different things. If I just had memory to throw at the problem, I'd say just optimize for time and use as much memory as you like. If I'm running this on like a really tiny like piece of hardware and it has like no memory, I'll say optimize for time instead. Yeah.
Will the string that you give me include numbers or include non-alphabetical characters?
Sure, that'd be a great question. So I would say like, okay, for now assume it's only characters. But if it were numbers, the map would still handle it because you can treat it as a character still. Yeah.
Does white space matter?
Sure, that's a great question too, right? So if I give you white space, if I say this exact question, right? If I told you that I don't care about capitalization or it's not case sensitive, and I gave you like 3 white spaces at the beginning, should you care about that? I would say that, yeah, we do care about that. And if there are spaces, then there should also be spaces in the permuted string. Cool, good question. Anything else? Yeah, that's the main one. This is the optimal solution for this sort of question. So yeah, good approach. You actually go back to your slow approach. Cool. So yeah, so after you're done asking clarifying questions, decide on your data structure and the general algorithm, and talk your interviewer through your general algorithm first before you start writing code. So writing the function signature is fine. So for example, writing like bool, permutation, string S1, S2 is fine, because that's just like really basic stuff. And then talk about the approach first. The same way I sort of had him explain the approach first without coding, you would do that at the beginning of the problem. Explain your approach first, and then the really sort of like hack or cheat here is you should confirm with your interviewer whether that's a good approach. So after you're done explaining it, you can say, does this sound like a good way to go? And at that point, they might say, sure, but I want you to optimize for more space or for more time. And in that case, you can alter your approach a little bit more. So this is kind of a hack, an ACM cheat. Once they've said, like, yeah, that sounds great, go ahead and write it. So write steadily, so not like slowly, but like just constantly sort of like write slowly, think through what you're writing, and explain the code that you're writing. Like actually explain what it does, how it's helping you get to the solution. Then you want to test with some example inputs. So you did a great job of testing with BAT at the very beginning when I didn't ask for it, but you did. So you should definitely do that on your own. Don't wait for them to tell you to test it. You should be testing the code on your own anyways. And then fix bugs, because you'll always find bugs in your code as you go through. So for example, like right now, this would work for an empty string, I think. But for some reason, like say an empty string like would break your program, you might want to throw a catch in for that, or an if statement for that. So fix bugs as you're going through. So like handle those edge cases, and then at the very end, always mention time and space complexity. You want to try to make them ask you as little as possible about your question. They'll always have questions at the end, like how does this scale? Does this work with strings that are like 1 billion characters long? You never really know. Cool. So this is a bonus. This is a system design question. So again, this is probably what you've heard the least of because it's sort of a new topic for most people. And it really focuses on can you design a system of code that scales. This doesn't focus on writing code. Instead, you write sort of diagrams to explain how you're going to be handling stuff. Yeah, so I think it's best explained if we kind of look at the question. Okay. All right. So they've all been real interview questions. This was a very interesting real interview question that I was asked. So we have an incoming stream of ticker objects, and you want to design functionality to create, read, update, and delete these tickers. Does anyone want to try this? It's really fun. Like no, most people here probably haven't heard about system design questions, so don't be afraid to volunteer. Anyone?
Wait, what are we supposed to do?
Yeah, so exactly. So that's perfectly fine, right? So what I'm really asking here is like, so we have these ticker objects, right? And I'm not going to tell you what a ticker object is yet because that's kind of your job. But so we have these incoming objects, and we want to design functionality to create, read, update, and delete these tickers. So I was asked this at a Bloomberg interview, and the exact question was basically this. Like, this is what came out of my mouth. And you know, the first question I said was like, okay, what's a ticker? Because I have no idea what a ticker is. It's kind of just like it's industry knowledge. It's industry knowledge. I don't really know what a ticker is, so I just asked them that. What I'm really asking here is explain overall approaches to create tickers, to read tickers from some sort of database or some sort of data structure, to update these tickers and to delete them. Does that give you a better idea of what I'm sort of asking for?
Yeah, but I mean, like, do you want us to code it or just like?
So no, you can just talk about your general approach. So, okay, so it's a little difficult. Do you want to do this, or do you want me to just like sort of step through approach?
Go ahead.
Okay, go ahead. You can go to the next question. Okay, cool. So first question, what's a ticker, right? Like no one really knows what a ticker is. Okay, so I'll define a ticker as this work. All right, cool. Not that. Okay. All right, I'll define a ticker as an object that's given to me with a time string, a name, and a value, right? And the name might be something like AAPL for Apple stock. And the value might be the number, which we'll assume it's like $6,000.
Apple's very valuable.
Yeah, in this scenario, it's very valuable. And the time string will be some ISO string. You don't have to worry so much about that, but just assume it's some string that you can sort by. That's very important. So that's a ticker object. So now we want to design sort of the API, or sort of like the function signatures of what creating, reading, updating, and deleting looks like. So what should creating a ticker object like look like? What should the function signature of that be?
Constructor.
Sorry?
A constructor?
Yeah, so there will be a constructor for this. We're assuming that they're going to give us a ticker object, and we're just going to store it in a database.
Oh, I see.
Right? So first off, like, what are, James?
Is there like some specific number, like some specific way you can tell one ticker from another ticker, like a ID or something?
Yeah, so there's no specific ID, so that's interesting. You can create an ID, but it'll make it easier if I give it an ID. So sure, good question. So we'll give it some sort of unique ID. And that's important in case you ever need to find a ticker, right? If you have the unique ID, it's very easy to do. Yeah, okay. So anyone have an idea of what a function signature for this would look like? Assume that we have a database. We're going to receive this ticker object, and we're going to store it in the database. You don't have to think about code, just literally what the function signature looks like. Anyone?
It would just pass into object, right?
Yeah, cool. So what would we return?
Boolean.
Sure, whether or not it was successful, right? Cool. So create might look like bool, create, and I might just take a ticker. And I'll call it T. So that's it, right? That's for create, yeah.
This would be a member function of the database?
You don't really have to worry so much about that. What I'm really going to try to get to is like how you're going to create it actually. So how you're going to be storing the tickers. But yeah, you would be right. So this would be stored on a route on your API, which would receive a ticker object and sort of like the post data, and you would put it into your database. Cool. So that's what create looks like. What would a read look like? So I'll tell you that for a read, we want to be able to fetch a series of tickers based off of a start and an end time string. So I'll give you sort of like Saturday morning in ISO string and Monday morning. And I want you to fetch all the ticker objects that we received within those time strings.
Should I return a vector of tickers?
Sure. Yeah, that's fine.
Okay.
So we can return a vector of tickers, and I'll call it find. And what do we take it?
Of int value? Of the time?
Yeah, so it's a string.
String?
But that's
Oh, sorry,
fine.
yeah.
Sure. So we'll take a start string and an end string, right?
Mhm.
Okay, cool. So I'll just call it start. We know it's string, so that's fine. Cool. So that's reading.
Mhm.
What about updates? So how are we going to update a ticker? Based off of what value can we find a unique ticker?
ID.
Time string, maybe. But this is going to be a huge, like the focus of system design questions is to work on problems at scale, right? So we might actually be getting thousands of tickers per second. So they would have identical time strings.
Mhm.
Yeah.
We use the ID, and then we can drop all this into the hash table, and the hash table, like, we can use the ID and hash it.
Sure.
So we know exactly which array we need to
Mhm.
go for, and then we can just pull that, we can grab that specific array.
Sure. That sounds fine. What do you want a return type to be?
Return type to be a ticker.
Sure. So we can return the new ticker info that we have right after the update. So that's fine. So we'll return a ticker pointer, and I'll call this update. And what are we going to pass in? What do we need to pass in to update? James?
The data we need to read.
Okay, sure. So we can pass in the data. So can we pass in just a new ticker object?
You pass in a new one and see what you need to compare to what changed between the
Yeah,
last one.
and that's implementation, right? So we don't really have to worry so much about it. Cool. So we can pass in a ticker object here. And this would be the new object, and we would override this ticker, like James said, needs to have the ID match. So we're going to look in our database for a ticker with that ID, and we're going to update it to whatever this ticker, the information has. So maybe we realize after the fact that the value was actually incorrect. For some reason, it gave us an incorrect value. So we can go back and change this. Cool. So last one, deleting. So what's a return type for delete? What can we return for a delete function?
Bool.
A bool? Yeah, sure. Whether or not we were able to delete it, right? Was there an error on the server? And what do you want to pass in?
Clicker.
Do we need to pass in an entire ticker?
ID. So string.
Right, yeah, we
yeah,
just pass in the ID and fetch by it, right?
Yeah.
Cool. So we'll just pass in sort of like a string ID. Cool. So that's the API. So that's step one, right? Yeah.
Would it be advantageous to just return the ticker you're deleting in case you want to do something with that later on?
Sure, that would be fine too. I think for now we'll just return a bool because I don't want to rewrite it. But that's your choice, right? So you can say that, sure, I want to return it. So the next part, so we define the API. So the next part, we want to decide on the data structure you're going to use. What do you guys think is an efficient method for storing the tickers? Keeping in mind that we want to create, so let's start by just optimizing the finding. Because the creating will happen pretty often, but we're also going to be finding very, very often. And we want to find based off a range, so like a time string range. What sort of data structure would you use to store it?
A JSON object, maybe?
A JSON object might work. What would your key be?
Probably the ID, right?
Okay. What would be the time complexity of you trying to find objects based off of a time string?
Probably. Oh, off of a time string?
Yeah. Based off a range of time strings, right? Remembering that like we have a start string and an end string, and we want to find all of the tickers based off of that.
Oh, I see.
Yeah.
Yeah, it'd probably be, would it be oven?
It would have to be oven because you have to go through all of your objects. But I think oven is the best we can do right now. So oven's fine. So sure, you said a hash map or like a map.
Like a JSON object.
Yeah, that's fine.
Basically.
So
same thing.
we can store a JSON object that maps an ID you said to the ticker object, right?
That works.
Yeah, and that's perfectly fine. can you give me a quick rundown of time complexity for all of those functions if we're doing it that way?
If we wanted to create, it'd probably be O of 1,
Yep.
because you'd just be putting it at the end.
Yeah, you just sort of like tack on the ID there.
And then find would be O of n, worst
Right.
case. What does that say, upload? Update. That would probably be O of n as well, because you'd have to find.
So you're passed in a ticker, right? And this ticker, it has to have an ID. It's guaranteed to have an ID. So what would it be in that
Oh,
case?
so it would be O of 1 in that
Right,
case.
perfect. So we have O of 1, O of n, O of 1, and what's the last
And
one?
delete would be O of 1.
O of 1 as well.
Yeah.
I think that's pretty good. Find is a little slow,
Yeah.
right? But I think that's the fastest we can get it for now.
Yeah.
Can you get it faster if you had 2 data structures? I'm thinking just like a little bit faster than O of n.
I'm still thinking.
Sure.
Yeah.
Anyone else? Yeah.
If you store it in a map, wouldn't it be all one?
Reading. So this is based off of a start and an end time string, right? So a map finding is only O of 1 if you're finding based off the key. So yeah.
Would you have an object that had times that also held the ID inside of it, so it's already broken up
Sure.
for you?
So okay, yeah. Let's walk through like why that doesn't work. So okay, say we have times like 1, 2, 3, right?
Mm-hmm.
And 4. And I return that I want all the ticker objects between the ranges 2 and 4.
Mm-hmm.
So you can return 2 and you can return 4, but you still need to go through everything to return the 3, right?
Oh, yeah.
Because you don't know what the range is.
That's true. Okay.
Yeah.
Or is there a type of data structure that stores everything by its content instead of the type of ID that you're passing in?
So how are you thinking of doing this then? So when you say store by content,
Yeah.
what are you talking about?
So if a ticker is guaranteed to always have the same like 3 kinds of things, maybe you could store by never mind. Bad idea.
That's okay. That's fine. Yeah.
Well, okay. What if we just store it like in a dictionary, and then we can with the start string, or like the vehicle ID is going to be like a string, right?
Which one?
The ID is going to be like
The ID is a string. You can assume all of them are strings.
Okay, so
Yeah.
and in the ticker we're gonna have a start string, right?
Yep.
So let's have the key of the dictionary be the start string,
Okay.
and then after that, if we wanna like get a range between start string x and end string y, we can just loop through. We can create a loop for x to y, get the dictionary at x. See what I mean? So like for I between x and y. Get the dictionary at I. So it's not O of n, it would be like O of the range.
Yeah, exactly. So that's what I had said at the interview as well. So it does work slow. It's very slow the first time, but it's quicker afterwards. So what you're sort of talking about is I'll search for 2 to 4, and I'll get some, and the first time I do this, I'll actually have to go through this map. Because again, I don't know, right? The second time I go through, I can store it like this. Like I can have... God damn it. Cool. So I can have sort of an object that also stores it by range. And that could be like 2, 4. They're all stuck. You want to throw me a whiteboard marker? Okay, no, I'm good. Cool. Wait, no, I'm not. Cool. So we can store it by range and store like a vector of arrays, right? Or of tickers. So, yeah, sure, I'll take it. Oh, yay. Cool. Cool. So we can do this, but let's assume that I'm not going to search for the same range very often. So I'll search for different ranges. So I might search 1 to 3, 2 to 4, 3 to 4, 1 to 2. But I'm not going to search 2 to 4 multiple times. Anyone? Cool. Yeah?
What if you made a linked list of every ticker as you came in? And to find, you don't directly pull the linked list. You make yourself a map. And what you can take in as a key would be a time string. And then the value that the key would return would be a pointer within the linked list.
So this is very close to the final answer.
Yeah.
Very, very close. Like, literally right there. Okay, cool. So linked list is kind of what I'm getting at here. So we have a linked list. And, okay, cool. I'll just do this now. We'll assume that we know the size of the linked list because that can be an implementation detail for the create function. Every time we create, we'll add one to a size, and every time we delete, we'll delete from the size, right? So it'll work very similar to a vector. And then our map will still be an ID. And the ticker, it'll actually be a ticker pointer that will point to some node in this linked list, right? So deleting is still fine, creating is still fine, because we can just create at the end. Then, now for this final like read part, you can do a binary search on this linked list, or a vector. You could choose either one. I just chose linked list because deleting seemed a little bit more natural to me. And it's easier because like if you're in the middle, you just do a very quick delete. It's not O of n delete like a vector would be. So what you can do for reading is you can actually binary search over this linked list, which is a little bit faster than O of n. It would be a log of n.
Finding for
you can
ID
find
or
the
finding
start string. You can find the start string.
Oh, well, the dictionary would be sorted by time string. So that would be ON or
So
constant.
the problem with storing it with time string is I might even give you a value that's not directly in the, no, I guess, okay. So I might even give you a range that's not directly in this, like with these numbers. So I might give you a range of like 2.5 and 4.5. Right? Because these are time strings. I'm just using 1, 2, 3, 4 as an example. Time strings can be milliseconds apart. So I might give you the 1st of December to the 1st of January, the 1st of December to like the 31st of December, and I'll just give you the times at midnight. But you might not necessarily have an object that came in at midnight on December 1st that you can start going from, right? So that's why this approach makes a little bit more sense. You can find the closest value in your linked list that's the closest to your actual start time, and then the closest to your end time, and then query everything in between. Cool. Yeah, so that's all 4 of these functions. That's sort of like, I guess like it's what I answered, and he sort of just said it was what he was expecting. So that's cool. So you want to optimize after every method. This is just sort of, again, just general approach stuff for system design. So when I said that this is O of n, Patrick knew it was kind of a problem that it could be faster. Then you start optimizing, like what are other data structures you can use, what are other algorithms you can use. You want to handle these sort of like worst case scenarios. So that's by accounting for time and space complexity. Stuff like this, where I'm not giving you the exact time string, but giving you a range. That's sort of like a worst case scenario that you want to handle. Other worst case scenarios, if you have increased server load, that's like you're getting, say, like 1 billion requests a second or a minute, right? How are you handling that? So this is through stuff like sharding or load balancing, which, quick description, if you don't know about sharding, so basically, I'm going to erase this. Everyone's checked in, right? Everyone checked in, cool. All right, so sharding is basically a method of having multiple servers that each have a portion of your total data in it. So say our example is like 1 to 10, right, instead of 1 to 4. I could store all the objects from 1 to 4 here, 5 to 8 here, and 9 to 10 here. So this way, each server has less data on it, and it's faster to retrieve. So this is sharding. Any questions about what sharding is or what it does? Cool. Yeah.
Like a blockchain?
Huh?
Like a blockchain.
Sure. Similar to a blockchain. A blockchain shards. So, yeah. Cool. Good for you. Another thing is to talk about load balancing. So maybe you have multiple clones of this, and you want to balance between the two. You can have master-slave servers, which is basically like if this server goes down, you want to maintain a duplicate here that you can instantly sort of like upgrade to be your actual server that data is going to. So it's small stuff like that. This will be like towards the end, like the last 10 minutes will be like, all right, now like a server goes down, what do you do? And you say, okay, well I have 2 copies of every server, so I should be good. Stuff like that, cool. That's system design questions. Any general questions about any of them? Anything? This is like the last slide I have, so I think last slide I have. Yeah?
Where do I find your internship at?
Oh, right, cool. Next slide. Yay! So this is sort of our recommended material if you sort of struggle with this or you don't know all of it yet. These are all some great materials to learn. So Cracking the Crane interview is like the interview prep book. You can check it out at the DSM library. So you should all become members and check stuff out. Programming Interviews Exposed is a great one. There are websites like HackerRank LeetCode, which are sort of question databases. Geeks for Geeks is cool because they store questions based on companies that companies ask. Interview Bit is a lot more sort of like learning focused. And Facebook also has an Interview Bit link that asks Facebook questions that are timed and that run and compile. Interview Cake, if you want to pay for it, it's like $159, but like don't pay for it. What you can do is they have weekly emails that send out programming questions every week. So it's just sort of a sort of weekly practice to stay up to date on it. You can also do mock interviews with ACM. So that's either me, Patrick, Daniel, someone, or you can do a mock interview with Facebook engineers. So they are coming this Thursday to sort of just handle mock interviews. You're not sort of judged on your interview skill at all. So like you're not gonna go to a mock interview, not do so well, and then they won't consider you for the actual interview. It's just really a chance for you to learn. So it's a great opportunity. Go ahead and sign up for that. And there's only like 6 people or so signed up right now, and they're here all day Thursday. So there's plenty of spots open. Yeah.
How do you sign up?
So those are links, and I'll be sending that out tonight.
Okay.
Yeah, it's also on the Facebook group. Just kind of like scroll through and you'll find it somewhere. It's a SurveyMonkey link.
How long is the checkout window for folks from the library?